Target Malaria Uganda, a research project at the Uganda Virus Research Institute, is developing genetically modified mosquitoes. Krystal Birungi, an entomologist, is the research and outreach associate at Target Malaria. She says the researchers and scientists are working to reduce the population of malaria mosquitoes to stop the transmission of the disease.
In the world, we have over 3,500 types of mosquito. But among those, there's about 3 or 4 that spread almost all the malaria that you hear about. Over 200 million infections a year, killing about 600,000 people every single year. So the goal of my work, of our project here, would be to reduce the numbers of only those particular types that spread malaria.
As one of the researchers, Birungi's childhood experiences drew her to this particular field of research.
Where we got sick almost every holiday, with no way to avoid it because we could not afford mosquito nets, which I'm sure many Ugandans can relate with, and where when you got sick, your parents may not even be able to afford the medication. So that was my life growing up. And really, no one is more motivated to find a solution to a problem than the affected people.
Countries with the highest malaria rates tend to be around the equatorial belt, where the tropical weather is conducive to mosquitoes. The top 3 countries for malaria infections are Nigeria, the Democratic Republic of Congo, and Uganda.
So methods like large-scale spraying of insecticides worked well in countries where they have seasons that are not favorable to mosquitoes. So let's look at South Africa. They have a very cold season, what they call winter. And at that point, the mosquitoes are few enough that you have a time when you can attack and expect to get almost every mosquito. Here, that is not a possibility.
For the last 10 years, Uganda loses about 16,000 children to malaria annually. The situation is exacerbated by drug resistance and insecticide resistance. The gene drive is being researched to be a complementary tool to fight malaria in Africa, working alongside bed nets, insecticides, drugs, and vaccines.
By changing this mosquito through a process called genetic modification. That just means you're changing the genes of this mosquito. And we're changing those genes by reducing the numbers of eggs that a mosquito can lay. Because one mosquito will lay up to 300 eggs after just biting somebody. So we said, okay, what if it laid 10 or no eggs? Then we could reduce those numbers of mosquitoes, giving us a chance to eliminate malaria.
By biasing the rate of inheritance of certain genes from one generation to another, gene drive can spread a modification to be passed on to all the mosquito population.
So you modified it, now it is laying less eggs. And then we add something called a gene drive to make sure that that change we have made to lay less eggs is passed down to every single offspring. What that does is that it makes the method more cost effective because it means you don't have to release 1 million mosquitoes to equal those that are in the wild.
The genetic modifications are introduced to the mosquito at the egg stage using special tiny injections.
What happens is we import eggs that have been specially modified in the lab, in that process. So we are not injecting the eggs from here yet, but we shall import those injected eggs. And then we have a special insectary or a building that has containment features, so things can't escape out or come in. And there the eggs are hatched and reared. And then those modified adult mosquitoes can then be bred or mated with mosquitoes we get from our environment to produce a mosquito with our genetic background.
For us to get eggs out of this cage, we have to feed the female mosquitoes on blood. We don't usually use humans to feed, though we feed them on human blood, which is sourced from the blood bank.
The insectary is regulated by the National Biosafety Committee and other ethical committees, including the National Environment Management Authority, or NEMA.
We have modified mosquitoes there right now that have something that we call a paternal male bias. So these are mosquitoes that have been modified so that the offspring they produce, when they produce eggs, 90% are male. Usually it would be 50-50. But male mosquitoes don't bite, so they don't spread malaria. And also if you have more male mosquitoes, it means you have less mosquitoes laying eggs.
Some sections of the public, though, have expressed misgivings about anything concerning genetic modification.
I would like to assure people that this kind of technology is heavily regulated. There are experts whose job it is to give permits, to give approvals, to study proposals, and really follow up and monitor. But for example, people might find it interesting to know that for people who are diabetics, that insulin they take every day is because of genetic modification. It is a modified product. And those people have not died because someone regulated it and studied it and only released it when it was safe. So genetic modification in itself is not necessarily a bad thing. Things evolve over time, even naturally.
The genetically modified mosquitoes have not yet been introduced to the environment.
So in 5 years, we hope to be doing field trials. For example, I've said we have proven populations will reduce in a cage. But that may not be the case if you put it outside, because in the cage, the mosquitoes have no choice. You have to mate with who is there. But what happens if I release you here where there are other mosquitoes? Maybe the other mosquitoes will look at you and say, this one doesn't look fertile. I don't know. So those are some tests we have to do.
Globally, the gene drive research began in 2005, but Uganda joined in 2013. Birungi calls on women to join such research fields to contribute to the elimination of malaria in the country and on the continent.
Because malaria disproportionately affects women. They're the primary caretakers in most of our households. So in this, when we're talking about sick children, about dying children, most of the time it is mothers that are missing time at work, that are really taking time trying to look after these sick children. It is girls that miss school to look after sick siblings. And yet, even as adults, most adults that are affected are pregnant women that are dying from malaria. And so when you're the most affected from a disease, really you should be part of the demographic that is talking about solving this problem.
At Target Malaria Uganda, the focus is on targeting only the 4 Anopheles mosquito species that are the main vectors of malaria in Africa. Gillian Nantume, NTV Tonight.